Hey everyone, we're here for our next talk. We have Terrence, who will be doing a talk from Prysmatic Labs, who will be doing a talk on ETH2, so beyond the beacon chain. And I'll let him take it from here.
Yep. Hey guys. Hey everyone. Thank you for having me, and thank you for the awesome organizer planning everything. I know that must be tough. So, quick intro. I'm Terrence from Prysmatic Labs. I'm part of the funding team, and we have been working on E2 since the inception. I think that's early 2018. And most of the news these days are about phase zero, right? Beacon chain proof of stake, which is very exciting. And I think Preston gave a talk a couple days ago on phase zero. But my talk today is more on phase one, like what goes beyond the beacon chain. I found phase one to be very interesting because that's when everything ties in together. And I've spent probably like 10% of my time on phase one when I'm not doing phase zero. So I'm gonna go over why phase one, current phase one scope, but keep in mind that there's still research that's ongoing. So basically, what I talk might be changed later, but that's okay. So let's quickly go over the ETH2 roadmap, right? So we have phase zero, the beacon chain, what we learn to love. There's testnets out there, which I encourage you to try those. And so we're pretty much close to completion with phase zero. We're just waiting for the deposit contract and waiting for mainnet. And comes phase zero, there's phase one, which is the shard chain, which gives us the scalability of data layer. And then there's phase 1.5, which we essentially wrap current ETH1 main chain into a shard. And so everything could be migrated there seamlessly. And then there's phase two, which is sharded execution. So today we have EVM. When it comes to phase two, we may have different execution engines such as Wasm, and maybe different transaction types and different opcode and basically all that awesome stuff, right? Let's quickly go over the phase zero features. And I'm pretty sure most of you guys are very familiar with phase zero at this point, so I don't want to bore you with details. But current Ethereum one main chain, right? The chain is simply a chain of blocks, and each block points to the previous block, and block contains transaction, and histories are these transactions in the order which they get submitted to the chain, right? So what is phase zero? Phase zero is this beacon chain, is this new proof of stake chain. And but why phase zero, right? Why is phase zero so important? So phase zero to me is like this foundation, right? It's like this building block that you build on the base layer, and then you need that in order to keep going. You need that in order to have shards, right? So couple key phase zero features are it only handles validator level transactions, and it has consensus, which is proof of stake consensus. It uses finality gadget. It has this awesome crypto economic guarantee, which is finality. And then it has a different for choice rule than current Ethereum main chain. And then most importantly, it has pointers to the shard chain blocks and state. And this will be enabled as an extension in phase one. And currently there's phase zero testnet, such as Madesha and Zinken. So I encourage you to try those out and get yourself familiar with phase zero. So here, this is you can view this as a beacon chain. It's a central management chain used by validators, right? So this is the chain that we know, and then it's essentially where validator stores and downloads and verifies data. It's similar to ETH1 main chain, but with different consensus engine. And just to recap before we move on, beacon chain contains two kinds of information, right? It contains consensus critical information. So who are the current validators are, what rewards penalties have assigned to them, how they deposit, how they withdraw. And then when it comes later, I will emphasize beacon chain also has pointers to the shard chain blocks and the shard state. So let's quickly go through some of the awesome phase 1 feature, right? So, as I mentioned, right, in the current ETH1 architecture for phase 0, we have the beacon chain, and then it's a proof of stake consensus chain. It's the foundation. So comes phase 1, we'll have shard chains, and then currently it's set to 64 shards, and we'll make extensions to the phase 0 design of beacon chain to facilitate the new features that's added for phase 1, right? So the most important feature of phase 1 is sharding. So let's take a look at the shard chains and its functionalities, right? It contains user level transactions. So this is when users can actually come into play, right? It doesn't contain any consensus related functions. That's what beacon chain does. So every block in the shard chain is fully downloaded and verified by the small portion of nodes. And that's essentially what sharding is about, right? And as a user, you can choose which shard you publish transactions to or contracts to. And it's also possible to move shards or coins. Sorry, it's possible to move coins and contracts between different shards, but only asynchronously. So here, this is a very simple diagram that I drew. So in the middle, you have this beacon chain. And then on the top, you have a top shard. On the bottom, you have the bottom shard. And then you can see how everything is linked together. And so shard block directly references to the previous shard block and also to the beacon block in the same shard, right? And the trick part is the shard block doesn't contain a post-state root like beacon block does. This is because of beacon state already handled that already. This is what essentially what stateless means. And then all the shard chains and beacon chains are tightly coupled together through what's called Crosslink, and I will go through that later. And Crosslink is essentially a signature for the shard block. It's signed by the random committee of minimum 120 validators. There are essentially a validator here is the consensus participating proof of stake node, right? So for a shard block to be valid, right, it has to be available, valid, and also referenced by the beacon chain block. And that's how you guarantee safety. That's how you guarantee that different shard block can talk to each other, and that's how cross-shard communication happens. But if a shard chain ends up linking to an invalid shard block, right, this can only happen during a 51% attack. Then that means the beacon chain is invalid, and that means that you kind of have to reorg and revert back. But the fortress handles that, so that's no worries. And like Clang is also vulnerable to such attack as well. So I'm gonna quickly go through what cross-linking means in this context, because of there's so much data in the shards, right? For every single node to verify all of it. So example, current ETH1 main chain, every node verifies every transactions for every block, right? And comes sharding this, and we can eliminate this assumption, right? So node only verifies the block, the transactions that they get assigned to if you're a validator. And that's why ETH2 relies on random community and random community to verify that shard block headers gets included inside the beacon chain. So shard block contains a parent root, and then beacon root, and then the body, which is essentially a byte list, and that's what the user submit. So here you have essentially a shard block that gets proposed, and then the committees gets randomly assigned that votes on the shard block. If it reaches the 2/3 threshold, then this shard block, the post root of this shard block gets essentially linked into the beacon chain. And whoever wants to talk to this shard block for cross-shard communication use that shard root, and this is how essentially shard Y here talks to shard X. So the next few slides will go through more cross-linking scenarios, more on the ideal case and some not happy case, right? So right now, you essentially have a beacon blocks in the middle, and you have top shard and bottom shard. And then, for example, if I want to send someone a coin, bubble coin at the bottom shard, I can essentially burn the coin and generate and then submit by burn as a receipt, and then it gets included in the state root A, and then whoever wants to consume my coin knows this receipt is safe, it's there because of the state root A gets included in the beacon block, and that's how cross-shard communication works. But this is the ideal case, right? So if you look at this is essentially one slot, like it happens within one slot, so 12 seconds in the current time frame. But it may not be ideal, right? There could be like skip block because of validators' proposals are offline, or there could be forks, right? But cross-linking still works in that type of condition, right? So here at bottom, you have a proposer that went offline, but then that's okay. You just wait until the next slot. So here B gets the state root of A with one slot delay. A more interesting condition, right? So I mean, there could be not enough validators online to submit the cross-link. Just to recap, for a cross-link to happen, you need 2/3 of the validators that vote for it, right? So here we don't have the cross-link because the validator is here. We somehow cannot reach 2/3 threshold to vote for this block right here, right? So we wait for this beacon blocks, the committee to vote, and then they were happy. So they're like, okay, we are 2/3 online, we're gonna vote, and then we vote for this block, and then B could see A through this cross-link right here. And then this is another simple conditions, which is you don't have a cross-link, but you're also offline, but it's similar. B could essentially get the context of the shard block A here. And then here, even a shard block could go missing as well, right? So here, this is even, now you have to wait 3-4 slots. And that's why I mentioned this happens asynchronously. So let's take a break from Crosslink. Let's talk a little bit about Light Client. Light Client is another very exciting features that comes to phase 1, right? So Light Client is as a committee is getting shuffled every day, every 27 hours. So meaning that as a Light Client, you pay attention to the committee to sync to the head of the chain. So that means you have less data to download, and you can sync to the chain faster. And so syncing the chain is only, you only need to download one block for every 27 hours or every day. So that means makes Light Client load very light, and then you can use it on cheaper hardwares. And then we also allow the committee to rotate pretty frequently and stuff like that. So that's another very exciting feature that comes with phase 1 that people hasn't really talked about. And let's talk more about like proof of custody, right? So phase 1, as we learned, is all about data, right? Like, how do we keep the data safe? How do we keep the data secure? How do we keep the data that ensure the data doesn't go missing, right? So to recap, validator, you have your duty for phase 0, but now you have additional duty for phase 1. And then your additional duty for phase 1 is essentially you have to download and process the user data. And then you have to keep you have to keep those data up to certain custody period, right? So there's additional hardware requirement that as a validator you have to pay more attention to. So there comes this type of game theory in play to ensure that validator actually downloads and secure the data, right? Because you don't want to have a lazy validator dilemma that validator just blindly follow what other validator does, right? So we have this big challenge game, chunk challenge game to ensure the validator correctly keeps the data, and then validator correctly computing the data, right? And then as a validator myself, I could challenge all other validators to make sure that they are behave honestly in terms of the work that they have to do. And then validators get rewards and penalties for playing this game. And then another exciting thing about phase one is this EIP 1559 related fee market, right? And I know everyone's very excited for EIP 1559 to happen in the mainnet, but and then comes phase one, this type of fee market is already built inside the protocol level. So you essentially have this block length. That's how much data the block contains. And then based on the previous block length and the current gas fees, you essentially determine a new gas price. And then the base fee gets burned. And then this is to prevent the proposer manipulates the fee. And then this also enables efficient gas estimation and then better UX. So yeah, so now we have phase 0 and then potentially phase 1 coming up in the next year. Now we have consensus and data availability, right? And also the ROPs are here, right? There's a lot of ROP testnets are there for people to try. And then Vitalik recently posted that with ETH1 and ROP, you get 1,000 to 4,000 TPS, assuming a lot of current dApps migrate to ROPs. And then comes ETH2 with phase 1. Now we can even offer more data across all the shards. Then you even get a higher TPS. And then Vitalik's post, he recently proposed this ROP-centric Ethereum roadmap, which says that comes phase 1, that we may probably get what we need, because of phase 1, we can have all those data, right? And then making changes like this also makes the base chain, beacon chain, more entrenched and more focused. And then there's lots of great work right now within the spec to essentially move towards this direction. Essentially, we can avoid this community and fraud-proof assumption. We can even increase the security of the beacon chain. And then we allow roll out to does its own thing. So where we are for phase 1, right? We have the spec out there. It's being heavily worked on, revamped. So if you're interested, check out the phase 1 spec. They're also very delightful to read, very interesting. And then there's also the phase 1 annotated spec as well by Vitalik. And this is more user-friendly version. It's not too much of Python code. It actually explains the rationales really well on why and how we do certain things. And not only for phase 1, even for phase 0, I would highly recommend to take a look at the annotated spec. I'm sure you will learn a lot of stuff there. So where we are in terms of implementation for phase 1. So from Prism's point of view, my team have been working on phase 1 in the background, but not too much effort spent there, just because we want to focus on phase 0. Phase 0 is the #1 priority, but for phase 1, I do spend like 10% of my time reading phase 1 on my during my downtime. So I have a Prism phase 1 client that's catching up with the phase 1 spec, and then that's hopefully in the next month or two, I can write a proof of concept simulation on that, so people can start trying it out. So I get this question a lot: how can you get involved, right? So there's a lot of things you can get involved. Like you can review the ongoing phase 1 spec, propose any questions, any concerns that you have. You can review the preliminary phase 1 implementations that we have on Prism, and then raise any questions. And there's lots of interesting phase 1 research topics out there, such as data availabilities, fraud proofs. And then phase 1 is also a networking piece as well, because there's different shards. You have different sharded network. And then how do you discover peers? How do you prevent DOS attack? itself is a different research beast. So it'd be cool to see someone simulate this type of sharded P2P network in such a large scale. So yeah, if you have any questions, feel free to join our Discord or ping me on Instagram. I'm happy to answer any questions. And yeah, that's all I have today. So thanks, guys. And if you have any questions.
Awesome. So I guess we can transition to the next session if there are no more questions. Cool. Awesome. Thanks, Terrence.
All right. Thank you.
All right. Thanks.